Hello, students. Hello, my lovely atoms. A very good afternoon to all of you. Hope all of you doing fantastically well and very much excited for the session. So, my class, there's a tiny mistake. I'll make sure it will get corrected. CBSE ninth class. This session is very much important because this is a mind map series that we all teachers had started just to help you all out and specifically beneficial for your exam time. That, ma'am, I have my exam in upcoming 3 days, maybe in a week, and I'm done with the syllabus, but I'm not getting the confidence that whether I'm doing good or not. So can I have something so that I can quickly revise everything and I can get that feeling that yeah, everything is stored here, I'm pretty confident now. So students, this is more of like a session that is going to help you in revising everything in almost around 45 minutes. So are you all with me? We are going to revise second chapter of CBSE 9th, and that is matter around us pure? Tell me. We have Sakina, Kritika. Hello, bache. Hello, Sakina. How are you? How are you doing? Mukund is also here. Yes, students. Anubha Gaur. My name is Anubha Gaur, your chemistry master teacher, your AG ma'am. Okay, I'm getting it corrected. This is CBSE ninth. Thank you so much. We have White Dwarf also. How's the Josh, guys? Keep the Josh high and don't forget to like the video. Please share among your friends. You can ask them also to join with me because more the merrier. More students, more communication, more doubt solving, and topic clarity 100%. Alka, thank you so much. Swarnima, Philip, can I send you my question paper? Mukund, why not? I would love to analyze your paper and let me know how did you do in your exam. Hello, Sandeep, Samiksha. Some topics are deleted from this chapter too. Divyesh, let me know when we are discussing and I'll try to help you. So let's start and let's have a target. Comparatively, students are less. Let's have a target of 250 likes. Can we achieve that? I am pretty much sure because I do believe in my students' power. These are like Hulk smash we can give. Okay, do that like. Don't just break your phone, by the way. All right, it was not you, Devesh. Okay. Science lost, ma'am, in Menti Trishal. I'm so sorry for the same. I tried my level best. I think you all have seen all the Menti sessions that your Anubha ma'am did prepare well. It's just my maths is not so well. Still, I was solving the question and tried my level best. It's okay, it's okay, it's okay. Shall we start, students? Your exams are over. Hriday, do let me know how did you do. Hopefully good and comparatively in a better place than the last year. Your best, Sebi best, but Amrit Sal is the villain of our mentee, you know. For science team, he was like a villain, and I'm like, you Thanos, I am like Hulk, and I'm coming, and I'll try to smash you. When I'll go back to my office, Bangalore, I'll try to go and give a Hulk smash to Amritsar. What say? Amritsar's live beating on Instagram. Okay, Kritika, all the very best. So, students, shall we start? Give me a quick thumbs up. Super excited. Is the matter round is pure? Don't forget, in the subscription box, there is a link with the help of which you can get all the courses of Vedantu at a super discount because AG Ma'am is there for you and AG Ma'am is pro here just to help you all out. So apply the code AGE Pro, you'll get 20% discount, students. The best part is session 2022 is started and you can enroll for the same. And 1 month pro price for this a month will be 2700, but if you apply the coupon code AJ Pro, Anubha Ma'am's coupon code, 1 month course for this upcoming year so that you can prepare well for your 10th class will be for 2160, and for entire year you can subscribe to Vedantu. I'm pretty sure you're going to have a wonderful experience. I am going to guide you as well, don't worry, in between the session. Okay, entire year price, like for all the 12 months from this March to the next March, 32,399. But come on, students, see the pro price after discount 25,909. So this is going to be a great deal. And don't miss this opportunity. Be a part of Vedantu in as low as 12 to 10 rupees per session. And I'm pretty sure you're going to have a very fantastic experience, because 10 rupees is like lesser than your 2-minute Maggie noodles. By the way, I love Maggie, huh? Like guilty pleasure, not that healthy, but yes. And tell me, students, is it something that you also come across? 2-minute Maggie is something that's not possible. Can you make Maggie in 2 minutes? For me, it takes around 8 minutes. What do you say? Justice for Maggie. I think for me, it takes at least 8 minutes. 2-minute Maggie. And I'm like, what? What are you talking? Oh, it makes 10 minutes. Like, ma'am being so accurate, 8 minutes. So, students, that's lesser than that, because Maggie cost 12 rupees. Yeah. But session cost 15 minutes. Session cost 10 rupees. So don't forget AG Pro. I'll tell you what all are the benefits you're going to get very soon. That you'll get all the live sessions, all the doubt solving in the session, and you'll be able to solve the doubts by we people unmuting you, and you can ask your doubt in that way, and replays wonderfully well, because you can play quizzes in the replay. Suppose I'm done with the topic and like, students, did you get it? Like, yeah ma'am, but not so sure. A quiz will be there so that you can make sure you get everything even in the replay. Replays won't be bored at Vedantu. So come and be a awesome part, and just make sure that your learning will be enhanced day by day. Okay, so let's start with the very first question. Lovely, Moria, lovely. Good to know that. Yes, Sakina. So Vedantu had already taken poll from the students, and we got to know that till 21st March, all of the ninth class students are having their exam. Majority, 71% poll said that yes, they are having exam till 21st. So yes, after that, we'll be on a break for 5-6 days, because you know that teachers also need a break. The entire year we worked very hard for all of you. So I think from 28th, 29th, we're going to start the next session. Yes, Kartike. Sure, sure, sure. In even on high flame, it takes 8 minutes. That's why I said. So let's start, students, and let's talk about classification of matter. Basically, you know about the matter in the very first chapter. What exactly is matter? Come on, students. I am looking for your responses. Is there Menti, ma'am? Kartike, it's a chapter revision which I tried to complete in 40-45 minutes. Yeah? Aditi, Vinod, how are you? Okay, yes, Sakina. So matter is something that is occupying space and carries a mass, like your AG ma'am. I'm sitting on a chair and I'm occupying too much of space and having like super duper mass. I just want to reduce some of my mass, but yeah, poor me. Okay, students. So matter is something that is having mass and occupying space also, and there are variety of matters around us, and there is so much necessary to classify the matter for ease, for our study becomes becoming so easy. For that purpose, we'll divide into two parts: pure and impure. Right, students? Keep interacting with me. Keep giving your response. Pure and impure. Impure is also called as mixture. On the basis of separation technique, I'm telling you how to separate it. If they can't be separated by chemical method, that's pure. If we can separate by we can't separate by physical method. We can't separate by physical method. It's pure. We can separate by physical method. That's impure. Simple. So my atoms, when kept on repeating, gives us element. Yes or no? You're from 8th class and started preparing for ninth class. Alka, I'm so happy to know. Dedication. In my time, can't imagine the same. Yes, yes. Same atoms, we get element, and we have 118 elements that we divide into metals, non-metals, and metalloid for easy study. And when molecules keep on repeating, when Same molecule keep on repeating. I'll try to change the color. I think that's not that visible. I'll try to take yellow. I think will be more visible. Okay, when same molecules kept on repeating, I will get my compound. Yes, yes. When just like water, H2O kept on repeating, we will get our compound. You'll be like, ma'am, you'll see two type of atom here, but why you calling it pure when pure means same kind of particle? Because molecule is a different kind of particle will keep on repeating. You're taking molecule as hydrogen oxygen here in particular case, not at all students. Take H2 as a whole one molecule. Why so? Because here hydrogen and oxygen are reacting chemically with each other, making chemical bond, and H2O is entirely different with entirely new property than from my hydrogen and oxygen. So you can't see as hydrogen and oxygen because it's carrying entirely different property from hydrogen oxygen. Take H2 as a molecule, kept on repeating, you get your compound. Okay, students? Yes, Kartike, very soon. And mixture? It's just a random thing. Two or more substances mixed together, and that we get our mixture, impure substance in any composition. You're like, let me make a lemonade, but I like, less sweet, and my brother likes too much sweet. So I'll put, suppose, one spoon of sugar, and he'll put 3 spoon of sugar. So my lemonade, my mixture will be different from his mixture, right? I'll take lemon juice, I'll take ice, I'll take soda, I'll take sugar, and I'll mix everything. Yes, students. So mixture is something in which we add two or more substances in any proportion, in random proportion, which is just having a physical change. Yes? Yes, Mukund. Molecule, we'll talk about in detail. That molecule is of two types. Molecule of element and molecule of compound. Element means when same atom repeats. Molecule is when two or more atoms combine together chemically. What is molecule, students? When two or more atoms combine together. When those two or more atoms are same, then we get molecule of element like this: hydrogen, ozone, nitrogen. These are the molecule but of element, because here same atom kept on repeating. Okay, and these are the molecule of compound, where I have two or more different atom combined together. So molecules are of two type: elements and compound. Yes, students, come on. Yes, Sakina, very nice, very nice. So pure substance, as I told you, we cannot separate by physical method. Like I have my water and I'm like, let me try to heat to separate hydrogen, oxygen. Let me try to just use some other method like filtering so that hydrogen, oxygen can be separated. Not possible. Okay, students? Crystal clear. Tell me. And mixture which is made up of different particle mixed in any composition. Harshal, I'm super awesome. Harshal, you're in 10th class if I'm not wrong. Tell me. Okay, students, so pure is of two type, as I told already: element and compound. Element is the purest form of matter because it is just having one type of atoms kept on repeating. And metal, non-metal, metalloid, we divide into three parts because they want us to be in that not so anxious state that who will remember 118 element. Not so good job. So just divide into three category on the basis of physical and chemical property. These are the elements follow same property. These are the elements follow same property, and so on. Metals are generally lustrous, shiny. Metals are ductile. Metal are malleable. Right, students? But came to take with my favorite AG ma'am. Yes, Harshal. Wonderful. Malleable means making very thin sheet. Ductile means making very thin wire, right? High melting and boiling point. Okay? But non-metals opposite property: non-lustrous, non-shiny, non-malleable, non-ductile, low melting and boiling point. Right, students? Metal good conductor of heat and electricity, non-metal poor conductor of heat and electricity, and metalloid follow the mixed property of metal and non-metal. Some property of metals and some of non-metal. Some property of metals and some of non-metals. Yes? Class was cancelled, ma'am. Your health is good or not? Harshal, my Wi-Fi is creating problem for me. Too much problem. So yeah, I have changed my router also, but I was all set to take session, and my internet was unstable and kept on, showing me that red signal. So yeah, that was not good for streaming. So I had to do that. English class make chemistry channel. Pratap 9th English means the entire 9th teachers of Hindi moved here almost just to teach you in English communication language because so many students were requesting for the same that we can't understand in Hindi. Okay. Thank you, Sachin. Let's talk about mixture now. Two type, homogeneous and heterogeneous. I think these two are very favorite word of yours. Yes or no? No, ma'am, it's just your saying. We don't believe in the same. Tell me, give metalloids give dhoka to us. Mixed property. Can you give example of metalloids too? Boron, silicon, germanium. Okay? Yes? Wonderful, wonderful. BCG in a way. Okay? You want to meet live in Electronic City. Just a minute. Want to meet you live. Harshal, I'm in my hometown right now. I'll be going back to Bangalore on 28th of March. After that, yes, for sure. Very nice. Awesome, guys. Awesome. Let's talk about mixture in detail. Mixture are of two types, students, homogeneous and heterogeneous. Homo means same. Genus, face. Nandini, I tried to come live yesterday also, but some, internet issue were there. And just before that, I took acid basis salt, one shot revision live only, just before some days. I tried to come live, just stay tuned. उसके लिए you all have to subscribe to the channel. Yeah, for the same you have to do that. Hetero means different, genus means phase. So homogeneous, when you mix all the particles, they'll go in a same phase. Just like I took a glass of water, put sugar and put salt. It's like so properly mixed. I'll be like, it's just water, can't have other substances. So when you mix two or more substances and they'll be in the same composition, uniform composition present in the entire part, that's homogeneous. And heterogeneous, when you try to mix, they'll be having a different phase like oil and water, chalk powder and water. We can see the separated phase. And when I talk about homogeneous two type, true solution and alloy, students, this is important part you have to keep in mind. Alloy is exactly what? Alloy, homogeneous mixture. Clear? Yes, Akina. I'll talk about the same. One shot of atoms and molecules already done, Kritika. Just check it out. Yes. Let's talk about true solution. My homogeneous mixture is basically true solution having particle size less than 1 nanometer. Because these are very small, let me tell you what exactly is 1 nanometer. Nano means 10 to the power minus 9 meter. 1 meters 10 to the power 1 upon 10 to the power ninth part. That is very, very small. 10 to the power minus ninth part of a meter. And when I talk about alloy, what will happen? Your metals are combining with other metal or non-metals to enhance the property of the given metal. They're like, metal is good, but I want to use it somewhere because here I need lesser melting point of this metal. So solder is an alloy of tin and lead, tin mixed with lead, and overall mixture melting point got decreased a bit. So just to enhance the property of metal, we mix it with other metal and non-metal. So mixture, true solution, and alloy is one of the type having lesser than 1 nanometer size. So small that we can't even see properly by a microscope. Yes? Yes, Sakina, talking about metals now, then it depends upon metal to metal, Sakina, which metal I have chosen. Suppose if I talk about hydrogen, which is just a non-metal, I'm talking about an element having a size of 0.375 nanometer, atom size of a hydrogen. So maybe whatever metal you have taken, they have particular size, but yeah, you can say that. Very less than a nanometer in general. Mukund, stainless steel alloy. Ma'am's bottle is from stainless steel. Okay, can you see that? So yeah, that's an alloy. Alloy of iron mixed with some carbon and nickel. Yes, and one more. Tell me what's that? Bronze. Harshal, in bronze we have copper. Copper's main alloy mixed with tin. That's what the alloy that we get in the as a medal also as a prize. Yes, okay. Let's see now. Heterogeneous is something that's of two types, suspension and colloid, totally depend upon its particle size. Suspension is having quite large size, larger than 100 nanometer, and colloid in between 1 to 100 nanometer. So colloid is like fake heterogeneous because it looks like homogeneous. It looks like homogeneous. Okay, particle size 1 to 100 nanometer, and they are like making us fool, they're like betraying us. So when we look, it looks like homogeneous only, just like milk and blood. It looks like all the particle is in same phase, but the particle present in milk, like fat particle and all, particle present in blood, like blood cells, red blood cell, white blood cells and all, these are suspended in your solvent, and particle size is comparatively large than homogeneous, so we can't keep into the category of homogeneous, so that has to belong to heterogeneous because of particle size more and suspended entirely in solvent. Solvent is something which is in more amount. Yes, students, solute is something which is in less amount and trying to dissolve in the solvent. Suspension, this is like true heterogeneous, not going to betray you, and you can see it properly. Like, yeah, I can see you, I can tell now. And example is definitely, as I said, oil in water, chalk powder in water, mud in water. Right, students? Not at all difficult. While doing chemistry experiments in lab, like आज तेरा भाई कुछ बड़ा करके दिखाएगा. Kartikeya and everyone, I had started chemistry practical on Hindi channel already. You're moving to 10th class, all of you, it is going to be very much beneficial if you see those videos. If you type class 10th practical chemistry, you will find the video. I'm done with almost 4 videos, and almost 4 are about to come one by one. Awesome, Khwahish. So your Khwahish is complete. I'm so happy. Shlok, are you a bit late? I have just explained homogeneous. That homo means same, genus means space. A solution in which all the particles are mixed so well and in a same uniform composition. And particle size is so less, that's why we can't see it even by a microscope. Less than a nanometer, like chalk in water, salt in water, sugar in water. So suspension is clear that we can totally see it by naked eyes, that you can't betray me. I'll tell you, you are suspension. And if we keep the solution undisturbed for some time, the particle can settle down. Okay, I'm talking about a solid and liquid kind of a mixture, just like chalk powder in water, sand in water. Those solid not going to be dissolved, particle size is very high, will settle down, and we can separate by sedimentation, right? Settling down and then separating by decantation. Are you getting this point? This is very much important to understand Tyndall effect, which is generally a property of heterogeneous mixture only, particularly colloid, but suspension can also show the Tyndall effect to you. See the perfect example in front of your eyes. What is Tyndall effect? We are passing a beam of light from a solution. When you pass a beam of light, light generally fall on those particles and scatter. Particle gets scattered in each and every direction. Sorry, not particle, light will fall on those particles, As soon as it strikes on those particles, it strikes, it scatters in all the direction, reaches to our eyes. As the light was striking and coming back to our eyes, that path is going to become visible for us. So what is Tyndall effect? Scattering of light and making that path visible. Scattering of light and making that path visible is Tyndall effect, which is generally a property of colloids as well as suspension only when all the particles of suspension are properly suspended in the solution. We have not taken that undisturbed form. We just shook it properly, and then we are trying to pass the light. So if you try to pass the light from milk, ink, which is colloid, if you try to take chalk powder, put it in water, shake it properly, stir it properly, then pass light, you can see the path will be visible to you. Scattering of light, yes, Harshal, that's the same thing only. That light gets scattered, that's what the Tyndall effect is. And the path will be visible, that's for sure, if light will scatter. Shivangi, you're my big fan. I'm so glad to know that. Thank you so much. Science paper on 19, Sakina, all the very best, all the very best. So students, colloid path is totally clear that particles of colloid are very fine, totally suspended in the solvent, size is 1 to 100 nanometer. They are quite stable because those particles, those are suspended, won't settle down at the bottom, and you can't pass through filter paper to separate those. Suppose I'm having milk and I'm like, let me separate the fat particle, let me separate the butter from the milk. You can't just filter the milk and can get the butter over your maybe that filter paper. Not possible, right? So colloid, you can't separate its particle from normal filtration at all. Centrifugation you can definitely do. What is centrifugation? Who will tell? Yes, Janisha, we can separate colloid by centrifugation. Taking the substance and rotating it at a very high speed so the particle can separate it. So if the particle is of high density, they'll settle down. If the particle is of lighter density than the solvent, they'll float. Just like milk will float over the, cream will be floating over the skimmed milk, that the fat, the milk without the fat. If I take blood, all the cell, RBC, WBC, red blood cell, white blood cell, settle down at the bottom. So depending upon the density. So the principle for centrifugation is mainly the difference in the density. Wonderful, just like washing machine, yay! I've seen a meme that they have taken a person as a washing machine and the other person was rotating him like this and then this. How washing machine works. This is so funny. Wonderful. So students, I'm going to show you a table which is going to be very important to you. Dispersed phase and dispersion medium. To find out these is very much important because colloid has different types. Special, a special text of अभिषेक सर और कोई काम नहीं है ना, they don't have any other work just to tease each other. That's the best work apart from obviously taking good sessions. Dispersed phase and dispersing medium is something that you should know. Dispersed phase is something that is your solute. Okay, another name of solute. Dispersing medium, that medium that's provided to mix the solute, that is solvent. Yeah. Okay, wonderful, wonderful. So this is a table, as I said, is going to be very important to you. Are you able to see this? And do let me know how many likes did we hit. At least I think we had crossed 100. We have to reach 250 at least till the end of the session. Solute, Mukund, less in amount. Solvent, more in amount. Remember, laminate. I don't know. I find this as a best example. I took so much of water. Water was needed to mix all those substances. Solvent, you put sugar, mix it. Salt, mix it. Lemon juice, mix it. These are the solute, lesser in amount, and need a solvent to mix together. Yes, Kartikeya. So these are the different type of colloids you all should know. Dispersing medium, dispersed substance. As I said, dispersing medium means solvent. Let me change the color. Yellow will not be visible here. Okay. Medium is your solvent, and dispersed substance will be your solute. You can always try to remember solute in solvent will be easy. So, liquid in gas, students, the best thing is imagine the winter days, you see the fog, right? You have so much of air. Air is solvent, and those condensed water particle, liquid. So, liquid in air. What exactly is this? Aerosol. Okay. Which type of aerosol? Liquid in gas. There's one more type of aerosol, solid aerosol, that is solid in gas. Just like the scenario of Delhi after Diwali. All those smoke particles were there in that entire gas, atmosphere, mixture of gases. So those smoke particles in the air, what exactly was that? That is also my aerosol. Aero comes from air in general, means a gas. Yes, textbook too, right? This table must be there in your textbook. Very nice, just smoke and all. Gas in liquid is your foam. Imagine gas and liquid when you have shaving cream and all, and when you try to, not you might have seen, they take that liquidish kind of a substance and they try to, just do this, they try to shake it and rub it, and then you see that will become thicker and forming because that gas got trapped inside it. So gas in that liquid gives a firm kind of a structure. Fire extinguisher, a very important example. So whipped cream, soap, and all. Emulsion is the best one to remember, an important one. Liquid in liquid, just like your milk. You'll be like, ma'am, how our milk is emulsion? Yes, I'm not talking about paint emulsion. Okay, milk here is your fat particle. Sometime you might have seen that whenever you make the milk hot, those fat particles starts floating on the top. Have you seen that? Have you observed that? It's just science everywhere. So did you see that? Yay! Awesome. Hello, Ipshita. Yes, so those fat particles are liquid only, mixed in that liquid. You know what? Your milk is 85% water. So much of water in your milk. And then milkman is like, okay, it won't work. Let me put some more water. So those fat liquids in water in a way. Aqueous form, what is that? Falguni, aqua. It came from aqua. Aqua means water. Aqueous means when you mix a substance in water. So you get a solution. Solution having solute and solvent, but the solvent is water. You get the solution by mixing it in water. फिर से धोखा. Shri, that was amazing. That was amazing. All right, all right. See, this solid and liquid is a very common one called as soul. And my paint, clay, gelatin are some of the example. Gas and solid is solid form. Gas and solid, you might have seen your styrofoam sheet that you use for projects also, that whenever you get anything in packing, you get that white color, very light sheet. That is styrofoam. And that is 95% air inside it. That's why it's very light. So that's small solid in so much of, the gas is trapped in the solid. Okay. So liquid in solid, solid emulsion, liquid in solid. It's like opposite. And that is my butter cheese. Solid in solid, my gemstone. People wear ruby, topaz and all, solid in solid kind of a mixture. Colloid is that. So you can take a screenshot also for the same. Jago is telling, ma'am, I love you. I love all my students, nahi? This will be good. I am escaping myself from such conversation. I love all my kids, my students. Okay. Students, let's move ahead. Let's talk about solution because I'm going to tell you very important numerical problems here. We are going to do that. Yes, 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 yes. Solute and solvent. When we talk about colloid, we call it dispersed phase and dispersion medium. when it comes to solution, we particularly call it solute and solvent. And students, I have given you an example that me and my bro were drinking a lemonade. And as I told that though I'm a sweet person, you all told me that, but I don't like too much of sugar in my lemonade or my tea. So what I do, I take a full glass of water. Suppose I have taken 250 ml of water and I put 1 spoon of sugar while making lemonade. In case of my bro, he takes same 250 ml of water but he put 3 spoon of sugar. So can you please tell me which lemonade will be concentrated? Which lemonade will be sweeter? Tell me, which lemonade will be sweeter? Can you say hi? Hello, Vyas. I'm here. Which lemonade will be sweeter? Let me tell you. Hi, Mishti. Hi, Vyas. Okay. Which lemonade will be sweeter? 3 spoon wala. That's so correct. So, concentration of that solution was higher because solute added some substance that was in less amount that was added. In my brother's, lemonade was more. So how to calculate which solution is, how much concentrated? We have some formula, and that is the total amount of solute taken, which is in the less amount, divided by total amount of solution taken. Solution is which we get from solute and solvent, which solvent. Okay, and concentration we try percentage, so we multiply by 100 also. Percent in 100, what's its percentage? So concentration of solution will be amount of solute, amount of solution into 100. Okay, very nice, very nice, very nice, everyone. It's buffering. Can you please try to refresh? Let me. Okay. Now is it fine? Less marks than, but then the fact is true that we'll not score good marks in both. That's not at all true, Shreyash. Who told you this? This is not at all true. Okay, guys, please try to refresh. I'll try to do. Yes, yes, yes. Mukund? Okay. You got the formula, amount of solute, amount of solution into 100. And in general, there are 3 techniques with the help of which you can do that. Mass upon mass, mass by volume, and volume by volume concentration. What does that mean? Means the solute I have taken is also in mass, means solid, means gram, and the entire solution I'm going to get, I'm also taking it in gram. Mass by volume, the amount of solute I am taking in mass only, gram only, and below that the entire solution I'm taking as volume, means liter, milliliter and something. Volume by volume, my concentration and also volume means ml, and the entire solution, that is solute plus solvent, that I'm taking is also in ml or liter. Okay. I'm sorry, Lata. I worked with all my best possibility to work on the same thing. Really don't know what exactly just happened, but still fine. Please focus on the session, okay? Please focus on the session. Okay? Let's talk about some separation technique, students, because this is also an important topic. Confusion between solution and solute and solvent. Ipsit, I think you were late. One of the students said the same thing and I had explained the same part. That solute less in amount, solvent more in amount. Solvent we need to mix the solute only. That's the work of solvent. Okay. Solvent spelling is bigger. The solvent is in more amount. Wow, 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 wow. So, students, let's get back to a very important topic, that is separation technique, how you can separate your mixture. Like, suppose I have salt and water, how can I separate my salt and water? So, whenever we get a mixture by some physical method, we can separate the two or more particles with the help of those physical method. Let's try to do some important one here. Let's try to do some important one here. Let's talk about the very first, and that is sublimation. Students, do remember that we'll always use sublimation in solid type of mixture. Got it? We use sublimation always in solid type of mixture when we have two or more solid. Sublimation we do when one of the solid can be easily converted to gas. And one of the example that we had taken is ammonium chloride along with salt. So when you heat it, ammonium chloride will convert to vapors, want to escape, but I have put cotton plug that can't go anywhere, and we'll remove the flame. Those particle will condense down here and going to submit on the funnel. So ammonium chloride will get on the funnel, and in the china dish our salt will be left. Okay, so we can separate my sublimable substance from a non-sublimable substance with the help of sublimation. One word bigger. Mishti, you guys are next level. As I always approach this also, that use acronyms and mnemonics, some funny things to remember the part that it's not easy for you to remember. That will be very helpful. Vedantu, the link seems to not work. Janisha, can you please tell me which link you're talking about? So students, evaporation is exactly what? A substance that is volatile in nature that can easily convert to vapors. A liquid that is volatile in nature can easily convert to vapor. I can separate it from a solid. So evaporation, solid in liquid. When do we use evaporation, students? Solid in liquid kind of a mixture. Okay, got it? Yeah, solid and liquid. And when the liquid is vaporizable, can convert to vapors easily. So I have taken salt and water and I started heating. What will happen? Water will left in form of vapor. Salt will be there on the uh, china dish if I had taken. One more example, I have taken ink and I'm like, ink is a mixture of dye along with water. And I want to get my dyes from water. So what I have taken, I have heated water and we are passing the heat to this petri dish. Petri dish glass dish is there. We have put our ink over there, and with the help of steam it is getting heated. We will give indirect heat, because if you directly heat it, these dyes can decompose. You won't get your dye at all. Okay, so we'll heat it indirectly in this petri dish. Your water will be evaporated and dye will be left. As I said, it's not a very good method because sometimes your substance can decompose, just like my sugar. If you try to heat sugar in water, water will evaporate it, then sugar can get charred. Sugar can decompose to give you black color molasses. So, not a very good technique. Yes? Chashni? Molasses. Mukund, more of like a black color, brownish color substance. We didn't want that. Yes, Nitin, ICSE date sheet has been changed as well. Why a diamond named as silver? Mishti, it's just a name. You can give some other name to me as well. Diamond will also fine with me. Okay, students, let's see this crystallization. Let's talk about crystallization. It's a very better technique evaporation, because in crystallization, we'll always get a pure substance without impurity. We are going to remove impurity. In evaporation, when we are heating it, impurity can still there in the mixture, because only the volatile substance will go. What if my impurities are non-volatile? They won't go anywhere in evaporation. So crystallization is so good because impurities we are separating and also substance will not decompose, right? Crystallization, we are going to mix our impure sample in a solvent, means the one in which the substance can get dissolved. Suppose I have taken copper sulfate in impure mixture, I can put it in water. As soon as I mix in water, my insoluble impurity, they won't able to mix, will settle down. Suppose I have taken copper sulfate in water, insoluble impurity will settle down at the bottom and I can separate it, right? By just filtering, okay? If I'll filter it, my insoluble impurity will be gone and now I got a solution with maybe soluble impurity which I need to get rid of as well. How to get rid of soluble impurity? Solubility is a very main factor. I'm going to heat this mixture and making it saturated, super saturated, because when you heat it, solubility increases. But then you'll keep it for cooling. When the solution starts cooling, as the temperature decreases, solubility will decrease as well. Okay, so the salt which was dissolved in that water starts coming out. So your entire salt, your copper sulfate starts coming out, but impurities are still soluble in the liquid, in the solvent, so will be still there. I can filter this and I'll get my crystal of copper sulfate. This is crystallization, depends on the method of solubility, that we are going to decrease the solubility by cooling the mixture. By the same, my salt, as are not that much soluble in the solvent, starts coming out, and we get that. How can someone not concentrate when we have our silver, ma'am? Oh, thank you, Ipsita. Thank you so much. Come on, students, where we reach, please give me an update. Tell me, when do we use chromatography? Quickly tell me, when do we use chromatography? The word is giving you the answer. 73 only. We didn't even cross 150. Come on, bacha log. Come on, my atoms. So here, students, chromatography word itself means chroma plus graphy. I'll try my level best to make a video on chromatography and we'll post on 9th Hindi channel. Please see that, okay? In next week. Chroma means color and graphy means graph. So this is chromatography is a technique to separate the color component in form of a graph on a filter paper in general, because those color components which are soluble in a particular solvent can have a different extent of solubility with my given solvent, and we will get the different kind of a spot. Suppose this is filter paper, like 2 to 3 centimeter apart from edges, we'll put the ink with a drop. We can take what do we call it, capillary, and we can put some solvent over there. That's the one which will help us to give only one drop of the dye. It will be absorbed, the ink will be absorbed. We will take our beaker, the bigger one, okay, and then we are trying to hang this paper with the help of glass rod, putting sellotape over there. We just hanged it and there is solvent over there. The solvent is the one that is going to be soluble in that ink. So it just has to touch it, because otherwise if it will cross the ink spot, it will create problem, because the entire ink will come to the solution. Okay, so it starts rising, the water starts rising because water is absorbed by the paper, and when it reaches to this point and still going above, what will happen, my different component of that ink that it is having will get separated, because they are soluble at a different level with my ink. So we will get different spots, maybe a green one, maybe a yellow one, maybe a blue one, but at a different, suppose I'm putting it here, different spot, and let me use one more blue. In that way we'll get different spots. The upper one, the one that is going to cover the maximum distance, is the one that's the maximum soluble one. That's how we can separate it. That's how we can separate it. Okay? You use this method for painting. Mishti, will you teach me painting? Yeah? Bhumika, can you please refresh? Sakina, what you wanted to ask, bache? I didn't get it. The principle of chromatography is solubility, different solubility. And centrifugation, I have already taught you that this is a method generally we use for colloidal solution, because those suspended particles we cannot separate by filter paper. We'll rotate it at a high speed. My higher density particle will settle down and the lighter density particle will be at the top, and we can separate it. Okay? Sure? Yes. Okay, this one is very important. Why this is very important? This is distillation, and this is a method we use for liquid in liquid. Liquid in liquid kind of a mixture. Okay? When we mix two liquid, and these are the one that's totally soluble in each other. Two liquid we have taken and they are totally soluble with each other. Miscible, we'll get a miscible substances. Miscible liquids are the one that is totally able to mix into each other and we won't able to separate, like alcohol and water. I think you can connect to that example, alcohol and water. You might have seen in so many videos and all on so many platforms, they take whatever the alcohol and put water to dilute it, and you won't able to get that okay water is there, because they are miscible into each other. And when you get that mixture, we can separate the two liquid with the help of difference in their boiling point. Okay? And if the boiling point difference is more, like above 25 degrees Celsius, we use distillation. Lesser than 25 degrees Celsius, less difference in the boiling point, we use fractional distillation. Okay? Distill word itself means to purify. So we are going to purify the liquid. We are going to get a pure liquid. So what will we do, substance? What will we do in this case, students? We are going to heat this in a distillation flask, and at the top we'll be having a thermometer. And then what will happen, let me tell you, almost same kind of a thing, but in fractional distillation an extra fractionating column is there. Your mixture will get heated and your thermometer will tell a fixed reading at a point. Suppose alcohol and water. Alcohol boils at 78 degree, water boils at 100 degree. Your mixture is getting heat. Suppose temperature reached to 78 degree, then water vapor starts escaping and will pass. Here it can't go because it's closed. Will come to this part called as water condenser. Water we are passing and it will condense the vapor, condense to liquid. So here we are passing the water. This is a hollow tube from inside, and inside there is a pipe from which my vapors are coming. My vapors are coming, and at the outer part of it we are running water. And water will take the heat of vapor and condense it down, convert it into liquid, and those liquid particles will come to the solution. And we will get our alcohol here, the one that is having lesser boiling point in the flask, and the one that's having more boiling point will be there in that flask only. And now you must be thinking, ma'am, how do we get to know that my entire alcohol is gone? The entire alcohol we separated, because at that time thermometer reading will start increasing, because 78 degrees the boiling point of alcohol. At that point, remember latent heat of vaporization. Your temperature will not change until the entire alcohol will convert to vapor, because all the heat is taken by alcohol particle to convert into vapors. Latent heat, hidden heat, it will not rise the temperature. If temperature starts rising, that means the entire alcohol will be separated only, and now heat is given to water. Okay, now the heat is given to water. Yes, Janisha, if the question will come for 3 marks, you have to draw the diagram. And only difference with fractional distillation is this fractionating column is going to be extra. Why we need fractionating column, students? Because this is a column that is having glass beads When the boiling point difference between the two liquid is very less, suppose 5-6 degree, so both of the vapor can come at the same time and can interfere. So my glass beads are doing what? They are giving the surface area to vapor so that they can condense and convert to liquid. So the one that's having higher boiling point but still want to interfere. Suppose I'm talking about alcohol having boiling point 78 degree. My acetone, my nail polish remover, 60 degree. I have taken this mixture. Alcohol has lesser boiling point, wanted to escape, but acetone alcohol is also coming. But the alcohol is having higher boiling point. If these vapors start rising, as soon as they start rising with glass beads, they get so much of surface area that they'll condense down and come back to the flask. So my alcohol will be still there in the flask and only acetone vapor can make it to reach to the top and can separate it. So fractional distillation, we will use a fraction where we use glass beads. Yes? Wow, Sarita, I'm so happy to know. You know Arshpreet ma'am as well? Arshdeep ma'am. Okay. Bhumika, how are you? So, students, I think this is not something we had a little bit kind of a revision. We just had right now a very thorough revision of this entire chapter, that is mind maps in like short notes of his matter round is pure. So did you get everything? I tried my level best to make each and everything clear. The question that can come to your mind, I tried to solve those questions too. पेंटिंग सीखने के लिए आपको मेरे घर आना होगा. मिष्टी, no worries, just let me know. We can have online class, so forget that thing. We have to be there at home. We can still connect. Right? Like less temperature will condense in another flask? Yes, Mukund. But before going, just wanted to tell you that Vedantu platform is going to be awesome one. Students, don't miss this opportunity and enroll for the next year right now, where you will get unlimited live classes with unlimited quizzes in each and every session to make sure that you're learning everything. Okay, we'll get the data and we can repeat the topic accordingly. You learn in a very healthy environment with so many students, can see interactive replay. As I told, replays won't be bored. You can participate in the live quiz and come to leaderboard in the replay mode too, which you can never see anywhere. Just to make your learning more and more active, just to help you guys with the best possibility. You will be able to download each and every notes of each and every session with our own feedback, teachers feedback. This is super important. This is something even if you skip will be fine, but you should aware in text question discussion, so you will get the notes of the same with plenty of assignments and test discussion in every 15 days, so that it will be stored in your memory, because in 21 days if you want to revise things, you'll forget that. So that won't happen. Right now also there are so many crash courses going on, so many chapter based courses are going on, so you can start studying right now in a very less price if you apply the code, okay, AGE Pro. Okay, AGE Pro. Both code is mine only, but for this channel, English channel, it's AGE Pro. And for next year, the course which was supposedly for 3,000, you're just getting it in 2,400. And the code, as I said, AGE Pro. Okay? And for the entire year, if you get this, you will get that 20% extra discount to get the same in 25,919 for the entire 12 years. A session in as low as 12 to 10 rupees. Yes. Thank you, Mukund. Thank you. In case of any confusion, if you are not so sure how to do that, just connect to me. I'll try to help you. The link is there in the description box. Just click on it, select CBSE 10th and target 2022 if you'll apply for the next year. Means this academic year. Yeah? Very nice. If you are left with any kind of a doubt, please just put your doubts in the comment section and I'll see it and we'll try to come back and solve it. Thank you so much, my lovely students, to stay there till almost an hour. I hope this is going to be very fruitful for you only, and will be adding so much of knowledge. Don't forget to like the video, please share it among your friends, and please subscribe to the channel if you're new, because you won't miss any live video over there because of the same. So, your OP, thank you, Siddharth, thank you. Yes, Bhumika, for that also I've made a video on Hindi and English channel. You can follow that. Naam, your coupon code sounds like AGE Pro. Yes, AG Pro. Yes. Okay, students, that was awesome. See ya, students, next time. Until then, take care. Bye bye. Happy learning, my lovely atoms. Happy learning.